explain half-wave rectifier with series inductor filter. Half-wave rectifier with series inductor filter. So all of you know that of a rectifier circuit diagram, it is having a step down transformer. It is of a rectifier, series inductor filter. Why it is called as series inductor filter? Why the name came as series inductor filter? A series with load resistance. Yes, our filter component inductor is connected in series with load resistance. Here I am using a filter component as an inductor. That's why it is an inductor filter, and our inductor is connected in series with load resistance. That's why this is called a series inductor filter. Now, all of you know that the output waveform of a rectifier, is having a output. I will draw only output waveform of a rectifier. Of a rectifier allows only positive off cycles. For negative off cycles, the of a rectifier will give a zero output. Similarly, whenever positive off cycles are there, of a rectifier allows that positive off cycles. The negative off cycles, it will give a zero output. So it is a output at this point. It is a output at this point. Why? Because the diode is in forward bias for positive off cycle, and it is acting like a on switch. So it allows only positive off cycles. Whereas diode is a reverse bias for negative off cycles. So it doesn't allow negative off cycles. Okay, so it is a output waveform of a rectifier. When we will conduct an inductor filter, filter is used. It is a pulsing DC waveform. It is a pulsing DC. Pulsing DC means it consists of both AC as well as a DC components. So now I will give this input, this as an input to the filter circuit, means this as an input to the inductor. Now what will be our output? Means inductor allows only DC components and inductor blocks AC components. Why? Because inductor is acting like a short circuit for DC components. Why? Because DC components having a frequency 0. So for 0, X, what is the resistance for X is XL is equal to 2 pi FL. For 0 frequency, it will becomes a 0 resistance for this inductor. It is acting like a short circuit. Whereas for AC components, it is acting like a open circuit. So inductor allows DC components, it blocks the AC components. However, small AC components are present. So it is an output waveform of a inductor filter. So it is actually it is looking like a somewhat DC, but there is some fluctuations out there in this DC. That's why after this filter also we will use a voltage regulator for constant DC voltage. It is a output waveform with filter. It is an output waveform without filter. Without filter. Now, what is the equation for this waveform? Is all of you remember this equation? What is the equation for this one? I is equal to Im sin omega t from 0 to pi, from pi to 2 pi, our I equal to 0. So whereas this is it consists of both DC as well as small AC components also. That's why finally after filter we will use a voltage regulator for constant DC values. So what is the equation for this waveform? Is all of you remember this equation? equation for this waveform is a I is equal to Im by pi plus Im by 2 cos omega t, sorry, Im by 2 sin omega t, Im by 2 sin omega t minus 2 Im by pi cos 2 omega t by 3, next to minus 2 Im by pi cos 4 omega t by 15. So it is a equation for this waveform, means it is a output equation for half-wave rectifier with inductor filter. Now I want to find the ripple factor for this equation. All of you know that the ripple factor is represented with gamma. So what is the formula for ripple factor? Any one of you can tell what is the formula for ripple factor? So the
VR VDC.
Okay, VAC or VRMS, AC value by DC value. So VAC by VDC. So what is the DC component in this equation? It is my output equation. So what is the DC components in this equation? What is the DC component in this equation? What is the difference between AC and DC? Any one of you can tell what is the difference between AC and DC? So, is it AC signal or DC signal?
AC.
Is it AC signal or DC signal?
DC.
So, it is a DC and it is AC. So, AC is having a different values at different times. So, continuously changes are there in a analog signal, whereas in DC signal, it is a constant value. DC is a constant value. It is my output equation. In this, a sine waveform means it is a AC waveform. Cos waveform means it is also AC waveform. Is there any sine or cosine in our equation? Those are obviously those are AC waveforms only. So whereas Im by pi, this is a constant value. So only it is the only DC component. Okay, it is the only DC component in our equation. So is there any sine term or cosine term? It is a AC component. Whereas here it is a constant value, which is a Im by pi. So this constant value represents it is a DC component in our equation. So in our equation, we can write AC component by DC components. It is also written as IAC by IDC. Yes, IAC by IDC. So in this total equation, it is only DC component. So I can write this as IDC can be written as Im by pi. And it is also, all of you know that Im can be written as Vm by RL. So I can write this equation as Vm by pi into RL. So I got IDC equation. In order to find the ripple factor, we required IAC as well as IDC. I already have IDC equation. Now I want to find the IAC equation. Now I want to find the IAC equation. I want to find the IAC equation. How many AC components are exist in this output equation? We have only one DC component, so I directly find the IDC value, which is Im by pi. So we can also written as Im is also written as Vm by Rf plus RL. So Rf value is very, very small. That's why we are taking it as a Vm by RL. So how many AC components are exist in this equation? ఎన్ని ఏసీ కాంపోనెంట్స్ ఉన్నాయమ్మ ఇందులో? Is my voice is audible to everyone?
Yes, sir.
ఒక DC కాంపోనెంటే ఉందంటే రిమైనింగ్ అన్ని కూడా ఏసీ కాంపోనెంట్స్ ఏనమ్మా. సో ఇట్ ఈస్ ఏసీ కాంపోనెంట్. సైన్ అయినా కొసైన్ అయినా ఉందంటే ఇట్ ఈస్ ఏసీ కాంపోనెంట్. సో ఇది ఒక ఏసీ కాంపోనెంట్, ఇది ఏసీ కాంపోనెంట్, ఇవన్నీ ఏసీ కాంపోనెంట్. ఇంకా కంటిన్యూస్ గా ఏసీ కాంపోనెంట్స్ వస్తాయమ్మ. సో ఇవన్నీ హౌ వీ విల్ ఫైండ్ ఐఏసీ ఈక్వల్ టు రూట్ ఓవర్ ఇలా ఎక్కువ కాంపోనెంట్స్ ఉన్నప్పుడు IRMS 1 square. We have to find the IRMS value in this AC component. We will find the IRMS, which is nothing but a IRMS 1. In this AC component, I will find the IRMS, which is nothing but a IRMS 2 whole square. Plus if we are finding a IRMS 3, similar ga manki ila continuous ga untayamma IRMS 4. So IAC can be how I will find a IAC means if so many AC components are there, finally I will find the IAC, overall IAC as root over square of RMS value of a first AC component and RMS value of a second AC component, RMS value of a third AC component square. In this way, we will find a overall AC component in a multiple AC signals. మా 1-1 లో అందరికంటే ఎక్కువ SGPI ఎవరికి ఉందమ్మా?
జయశ్రీ సార్.
జయశ్రీ. రోల్ నెంబర్ ఎంత?
25 sir. 25 sir.
25. నెక్స్ట్ అమ్మా జయశ్రీ 25 సార్. ఫస్ట్
శిరీష.
శిరీష. రోల్ నెంబర్
3 sir.
3 answer. Okay, thank you. Okay, now in this way we will find a overall AC component. ikkada manaki chaala unnai kabatti first 2 AC components తీసుకుంటున్నాం. సో రిమైనింగ్ ఆల్ నెగ్లెక్ట్ చేసేస్తాను. ఫస్ట్ 2 RMS వాల్యూస్ తీసుకొని I will find a AC component. సో ఇవన్నీ నెగ్లెక్ట్ చేస్తాను. హైర్ ఆర్డర్ టర్మ్స్ అన్ని నెగ్లెక్ట్ చేసి ఫస్ట్ 2 RMS values కన్సిడర్ చేసుకుంటాను. So now I want to find the IRMS 1 as well as IRMS 2. It is in this AC component RMS value is a IRMS 1. Now let us consider if I have a signal like Im sin omega t and undanukunnam. What is the RMS value of this signal is a RMS value of this signal is a maximum value. Maximum value means ఈ సైన్ టర్మ్ కి ఏదైతే మనకి మల్టిప్లికేషన్ ఉందో కాన్స్టెంట్ వాల్యూ, దిస్ వాల్యూ ఇస్ కాల్డ్ యాజ్ ఎ మాక్సిమం వాల్యూ. మాక్సిమం వాల్యూ బై √2, Im by √2. We will find IRMS value like this equation. So how we will find IRMS? Let us consider it is a AC component Im sin omega t. In this I want to find the IRMS means maximum value. Maximum value అంటే ఏంటంటే మన సైన్ కి కోఎఫిషియంట్ లో కాన్స్టెంట్ వాల్యూ ఏదుందో దట్ వాల్యూ ఇస్ కాల్డ్ యాజ్ ఎ మాక్సిమం వాల్యూ. సో మాక్సిమం వాల్యూ బై √2. హియర్ ద మాక్సిమం వాల్యూ ఇస్ Im. So IRMS means Im by √2. Now any one of you can tell what is a IRMS 1 value for this AC component. I am finding a IRMS 1. For this AC component I will find a IRMS 2. So IRMS 1 value ఏమవుతుందమ్మా? What is the maximum value in this AC component? What is the maximum value in this AC component? మాక్సిమం వాల్యూ అంటే ఈ సైన్ టర్మ్ కి కోఎఫిషియంట్ ఏదైతే ఉందో అదే మాక్సిమం వాల్యూ అవుతుందమ్మా. సో ఈ సైన్ కి ఏమవుతుందమ్మా మాక్సిమం వాల్యూ?
Im by 2.
Yes, it is a maximum value. Im by 2 is the maximum value. So maximum value by root 2. So here I will get a Im by 2 root 2. So I can write it as Im can be written as here. When we are finding a AC component, we have to include this EL also. For DC component, it is acting like a short circuit, so it is having a zero resistance. That's why I didn't include it, this inductor when we are finding a DC value. But for AC component, doesn't work as a short circuit. It is having some resistance value. That's why we have to include this value also. So I can write Vm can be written as Im can be written as Vm by RL plus J omega L. ఇక్కడ ఎందుకు ఒమేగా ఎల్ కన్సిడర్ చేశాను, ఇక్కడ ఎందుకు కన్సిడర్ చేయలేదంటే ఫర్ కంప్యూటింగ్ ఏ DC component it is acting like a short circuit. For DC values it is having a zero resistance. That's why I didn't included this inductor resistance here. Whereas for AC component it offers some resistance value. That's why I included omega L here. Now if I want to find a magnitude, what is a magnitude RL plus J omega L ke magnitude find cheyalante ela find chestamamma, root over RL square plus omega L whole square. Vm by 2 root 2 into root over RL square plus omega L square. Whereas omega L value is much greater than RL. So omega L value is much greater than RL. That's why here we will neglect this RL value. If we neglect this RL value, what is the IRMS one I got here? IRMS1 equal to, if I neglect this value, why? Because here the omega L value is much greater than RL value. So if I neglected this RL value, what is the equation here I got?
Vm by 2 root 2 RL.
RL neglect chestunamma. Why? Because RL value is a very less. So what is the equation here I got?
Vm by 2 root 2 into omega L.
Yes, root over omega L whole square means square and square root gets cancelled. So here I got a IRMS1 as a Vm by 2 root 2 into omega L. It is a IRMS1. Similarly, now I want to find the IRMS2 value. So in second AC component, what is the maximum value here?
Minus 2Im by pi. 3 pi.
Neglect this. Yes, exactly. Total constant value minus neglect చేసాను, magnitude ఒకటే తీసుకుంటున్నాం కాబట్టి total multiplication for this sine or cosine we will consider it as a maximum value. So here the exactly right what one of your friend told that the maximum value is a 2Im by 3 pi. So here the maximum value is a 2Im by 3 pi, okay, into root 2. Why? Because maximum value by root 2. RMS value can be calculated as maximum value by root 2. Andike into root 2 chestunam. What is the Im can be written as here 2 by 3 root 2 pi into Im can be written as here Vm by
2 root 2.
Vm by same ఇక్కడ లాగేనమ్మా, ఇక్కడ ఏమొచ్చా Im can be written as Vm by RL plus
J omega L.
yes. What is here Vm here Im times Im ఇక్కడ ఏమొస్తుందమ్మా Vm by ఏమవుతుందమ్మా Vm by RL plus in place of here we have only omega. Here see here in place of omega what here we have 2 omega. In this AC component in place of omega we have a 2 omega. So what is here I will get RL plus J into 2 omega L. Vm by RL plus J omega L previous దాంట్లో అయితే వచ్చిందమ్మా. Vm by RL plus J omega L. But here in place of a omega we have a 2 omega. That's why here I am replacing this with 2 Vm by RL plus J 2 omega L. So here if I find the magnitude value, what is 2 Vm by magnitude కావాలంటే ఎలా ఫైండ్ చేస్తాం? 3 root 2 pi into root over RL square plus 2 omega L whole square. All of you know that here omega L value is much greater than RL. So we will neglect RL value. If I neglect RL value, what is the equation here I got? RL neglect చేసాను అనుకున్నాం, ఇక్కడ ఏమొస్తుందమ్మా ఈక్వేషన్? 2 Vm by
3 root 2 pi into 4 omega L.
4 omega L square root over. Means here I got 2 omega L వస్తుంది. So 2 gets cancelled. So finally here I got a Vm by 3 root 2 pi omega L. So it is a IRMS 2, it is a IRMS 1. Finally AC component can be AC component can be calculated as IRMS 1 square. మనం ఓన్లీ 2 కాంపోనెంట్స్ కన్సిడర్ చేసుకున్నాం ఇక్కడ. రిమైనింగ్ ఏసీ కాంపోనెంట్స్ హైయర్ ఆర్డర్ ఏసీ కాంపోనెంట్స్ అన్ని కన్సిడర్ చేసుకున్నాం. రూట్ ఓవర్ IRMS 1 square plus root over IRMS 2 square. So here I got the value. What is the IRMS 1? Here I got Vm by 2 root 2 omega L whole square plus Vm by 3 root 2 pi omega L whole square root over. చూడమ్మా, ఈ రెండింటిలో కామన్ గా ఏంటుంది? Vm by omega L కామన్ ఉందమ్మా. ఇక్కడ కూడా Vm by omega L కామన్ ఉందమ్మా. అది తీసాను అనుకో కామన్. సో కామన్ గా Vm square by omega L whole square. ఇక్కడ కూడా Vm square by omega L whole square వస్తుందమ్మా. రూట్ లోంచి బయటికి తెస్తుంది Vm by omega L కామన్ ఉంది కాబట్టి తీసాను. సో Vm by omega L into root over ఇక్కడ 1 by 2 root 2 whole square అంటే ఎంత వస్తుందమ్మా? 1 by 2 root 2 whole square. What is the value of 2 root 2 square?
8, sir.
So 1 by 8. ఇక్కడ ఏమొస్తుందమ్మా? 1 by ఇక్కడ ఏమొస్తుందమ్మా? 1 by 18 pi square. Okay, it is a value of a IAC. Finally we have to find the ripple factor, which is IAC by IDC. Final ga mana with filters అన్నింటికి కూడా ripple factor derive చేయాలి. Okay, so ripple factor can be written as AC component by DC component. AC component అంటే ఇదమ్మా, Vm by WL root over 1 by 8 plus 1 by 18 pi square by what is our IDC value? We got IDC ఏమొచ్చిందమ్మా? Vm by pi into RL. It is a IDC value. So in place of IDC I am replacing that Vm by pi into RL. So Vm cancel అయిపోద్దమ్మా. So here I got this value pi RL by omega L into root over 1 by 8 plus 1 by 18 pi square. Now it is our final ripple factor of a off-air rectifier with inductor filter. So ఎవరి దగ్గర క్యాలిక్యులేటర్ ఉంటే ఈ వాల్యూ ఫైండ్ చేయండమ్మా. pi into root over 1 by 18 plus 1 by 8 plus 1 by 18 pi square value. ఎవరి దగ్గర క్యాలిక్యులేటర్ ఉందా? 1/8 అంటే ఎంత వచ్చింది?
0.125.
0.125. 1/18 పై స్క్వేర్ కదా, ఇది 0.125 వచ్చింది మనకి. నెక్స్ట్ 1/18 పై స్క్వేర్ అంటే ఎంత వస్తుంది? 1 divided by 18 పై స్క్వేర్ వాల్యూ ఎంత? పై స్క్వేర్ వాల్యూ 3.14 into 3.14.
Sir, our square root value is 0.82, sir.
0.82 into pi చేయం అయితే.
Okay, sir.
One divided by ఇది 18 pi square value.
Sir, 2.577.
2 point అంత వచ్చింది వాల్యూ. ఒకసారి ఇది 18 pi square value 177.47 అమ్మ. సో 1 divided by 177
0.005, sir.
47 ఈ వాల్యూ 0.0056. ఓకే, సో ఇందాకల వాల్యూ ఎంత వచ్చిందమ్మా మనకి? 0.125.
125. Yes, sir.
125 ప్లస్ ఇది ఎంత వచ్చిందమ్మా?
0056.
0056 అమ్మ. ఇది మనకి ఎంత వచ్చింది? 0.1306. ఇది రూట్ చేయాలమ్మా.